My name is Terry. I'm tech lead at Apico from Ternopil, and I'm going to talk you about the experiments with JSI and the good and the bad parts. So, uh, right away, disclaimer: I'm not a native developer, and I have some experience with Ruby, Java, some kind of just Objective C, but my whole experiments, the whole story about experiments is based of some of the knowledge of those native languages, and so kind of C++ because I read that book, if you know what I mean, way back then. So, okay, today I'm going to tell you a story about one failure. At Apico, we develop lots of different React Native application. My role as a tech lead is to solve some hard cases, some problems we stack with. So, and the one of the biggest problems are is animations. Animations are hard. Change my mind. So, who agree? Okay. How many of you have created a fancy animation in last month? Not just like transition from one position to another by something more complex. Okay, how many of you have ever used the animated library which comes with React Native? Okay, what about React Native animatable? What about React Native reanimated? What about React Native reanimatable? Yeah, just add the re part and it's cooler now. Redux, yeah. We are going to talk about React Native Reanimated. It's basically the library which allows you to do some of the animation on the native thread, just like what said you on the previous talk. So basically, it's the re-implementation of the animated library, which comes with React Native, and it even shares some code with that, like it's basically lots of copy and paste into reanimated itself. And we all know how animated looks like. So basically, you have the animated import from React Native. Then you have some kind of animated value you created and pass the value. Then we animate that using animated timing, and don't forget to call start because I always forget. And the most important thing here is use native driver. Basically, it's the flag which allow us to run the animation on the native thread, basically on the even UI thread, because it will be 60 frames per second. Even if the JS thread will be blocked, it still be really smooth, and we won't notice that at all. So basically, that's the code we all used to write. But with reanimated, we can do basically the same. You can barely like notice the changes between those two, like with and this. The only thing is what changed that is the import. We are importing that animated from React Native reanimated, and also there's no use native driver. Why? Who knows why? Yeah, because it's already use native driver thing. So it's already running on the native thread. And basically that's kind of React Native reanimated you can use, but there is a better way to use reanimated, and the whole reason why it exists, because that's pretty much the same as use native driver. The whole reason it exists is the declarative programming. So basically it comes with lots of like nodes which are just functions, and you can compose them and create some logic. So basically it's something like DSL, like language. You can express some your logic, and it will be transferred to the native side through the bridge and will be executed on the native side. So basically you create the value still, you create the clock, we will talk about it later, and then you have the use code hook, which will tell reanimated to execute that block that's we wrote that as a React Native code, but that basically will be created on the native side, and that block will be executed on each and every frame. So basically on each frame it will be executed, and that set it basically the same as we do assignment in JavaScript, but to that value. And runtiming, it's basically a function which represents the timing animation, the same as we saw here, like that. Timing is basically the same, and it's just boilerplate you're going to copy and paste on each product and where you use reanimated. And we pass the clock. Clock is basically the loop. We will use the values of that loop. It's basically the time, like in milliseconds, and after each 16 milliseconds we will rerun that runtiming and return some value, like from 1 to 0 during the 1000 milliseconds, and that's it. That will be executed right away. Then you mount your components. So how does it work? Wart already said you lots of things about the thread, and I won't duplicate him, tell yet another one the same thing, but it basically goes through the bridge. Here is I have the example I will share with you as well, which have few different screens. Yeah, I don't use any of the React Native kinda solutions for navigation, because we all use some kind of animations, and I just wanted to get away from it and see the raw input of our bridge. I just spine on the bridge. So then I navigate to that screen that runs the animated, and basically you can see the all the messages which will be passed across the bridge. So as you can see, there are lots of them, but basically it's like 10 for creating that animation, like 7, and then another 6 to drop the animation. So basically it creates the animation representation on the native side, then drops it, then we remove that view we been animated. So reanimated pretty much does the same, because as I said, it's basically the same principle, the same code, but extended, and the same view. But notice the count of the nodes. Basically it let me 152 just initialize the animation and showed it, and then another 100 to drop it after it's done. So 10 times more, kinda. But what about if we use some, if we use reanimated it's in some real life case? Basically that one. We are navigating to the accordion with 5 of them on the screen, and it basically created more than 1000 calls over the bridge. And you can see, you can tell, is it really a lot? Well, you barely notice that on this simulator. You barely notice that on the some new iPhone or Android phone, but you will definitely notice that when you use some old iPhone, even iPhone 7, or even some cheapy Android phones, like $100. It will take 1 second to load that screen. So the problem here is when we do the creating the animation, it just blocks the thread. So basically, when we do lots of calls over the bridge, we block the thread. And basically, here is an example. Let me pixel. I believe in you. Okay, pixel is not working, but on the that one, that basically my phone, and it drops the JS thread. I'm not sure if you're familiar with that, but you basically can shake your phone, press on the perf monitor, and it will show that thing on both iOS and Android, where you can see the count of the frames, the app is showing you. So basically, then you open the animation, you can see it drop to the 34, and it's on my laptop. Imagine having that on your phone. Like laptop is more powerful than your phone, or especially if you have a old phone. So basically on my Pixel it drops to the 16 frames per second. But on some Android you will have a delay about 3 seconds, just showing nothing, up is frozen, and then it navigates to the screen. If you use some like React Native navigation solutions such as React Navigation, for example, you won't see the animation, like transition animation won't happen, because while the transition animation happens, we render the next screen, and that will you will see the delay, and then next screen will pop up over the previous one, and that's it, no animation. For such solution, native solutions such as React Native Navigation or Native Stack, for React Navigation, you will see just delay. It will freeze for a second or two, and then a transition will happen. You will see the next screen with animation. But still, any user will notice that, and it will be slow. Just for user, it will be slow. Believe me. So, okay. Oh, it's working. Cool. You can. I'm not sure you can notice that, but there was 16 frame per second. Okay. You are probably already thinking like, what is he talking about? We should have talked about JSI, but not the some reanimated stuff. So I tried to fix the performance of reanimated with JSI. I saw that talk. Uh, did you saw that? Did you see that talk by Ram at React Native Amsterdam? It was on last spring, and he was talking about JSI Turbo Module, how it gonna work, and when will we have that, and which problems it solves. So basically, I was really excited after that talk, but more excited I was then I saw that article. I will put the link. That basically article written by college, um, and he created JSI bridge for iOS implementation of reanimated, and it was 3 times faster than the async bridge. So lots of potential. Okay. So what is JSI? You're already wondering, like, if you're not familiar with that. So basically, JSI is a new bridge without serialization overhead. So we don't create JSON from our messages, calls like the messenger, and put them to the native and then back. We are using raw pointers and pass the value by pointers, if you're familiar with that concept. So basically, JSI stands for JavaScript interface. It's a glue between JavaScript and native. It does directly invoke, think it's kind of RPC, JavaScript or Java or Objective-C methods from the JavaScript. No serialization, deserialization overhead, so we don't deal with JSON stringify, send it JSON parse on the native side and then back. And you can create C++ native modules now. So no any additional things, just use the JSI to create bindings to your C++ native models, and that's probably the most important feature of the JSI. So basically, let's explain how it works. Console log is a popular way to debug. Who use console log to debug? Yeah. How many of you use debugger instead of console log? Three persons. Okay. So basically, you can console log something. That's uh, Chrome console. So all the examples from the Chrome console. So basically, you can console log something, and console log obviously logs something. But did you know you can call to string uh, on your function and see its code? How many of you knew it? Okay, let's explain. Basically, I define in a function, and I can call to string on that function, and it prints me the function, and you can pass that string to the eval and eval that code, basically. So let's try to use that toString thing trick on the console log. What it will show us? But it shows the native code, but not the code of the function. Why? Who knows why? Okay, let's explain it. Because console log isn't JavaScript function, it's a native function. You basically, then you call console log calling the native function. What native means? It basically the language, the platform is native for that stack. Basically, it's a Chrome console, and Chrome is written in C++. So basically, native is C++, and you are calling the C++ function from your JavaScript runtime. Yes, you can do that. Okay. Basically, it's attached the some of the kind of C++ logic to some of the JavaScript function, and you can invoke them and pass some value like we did here. Here. Uh, Not here, but here. Okay. Like here, we pass some value, and it basically passes it to the C++ runtime, logs, and gives some result to the JavaScript engine. Okay. Basically, JSI is a header library. It basically lots of definitions in C++ world that converts all the values from JS to C++ and back. So basically, we are not dealing with the serialization. We have some JavaScript object. We passing it to C++ side. It knows which type of the object it's like. It guesses which values, which types, and that's a complicated thing. But still, it converts it to the native structure on the C++ side. Then you can basically create some JavaScript not functions, objects, strings, values, anything you want on the C++ side, and then pass back to JavaScript runtime. And basically, JSI creates a representation of that JS values to C++, and we all know that all the iOS applications are written in, for example, Objective-C, Swift, maybe in C++, or maybe in Objective-C++, and basically that's native languages for the iOS part. But you can read about that more on the Christian's article, that JSI challenge article, and it's like in details explanation of how it works for iOS side. But I'm going to talk about Java, and if you're not familiar with Java, you still like familiar with some of the concepts like variables, methods, classes, maybe some callbacks, and that's it. So basically, that way, Objective-C works. Doesn't work for Java, and for Java we cannot invoke C++ code directly from Java. So we need a second layer called JSI. JSI stands for Java Native Interface, and basically the same as JSI but for Java. So you can call some C++ from Java and back. Okay, basically how it looks like: you have JavaScript core, you have the global object on the JavaScript core. You can call it like global and something. Then we go to the going to JSI. From JSI, it converts all the value to like C++ representation. Then we from C++ go into JNI and create all the required for Java things, and then we go into Java, and then like the same but on the back, like Java, JNI, C++, JSI, and JS runtime. Yeah, it's a bit complicated, but basically at the end you will get something like that. So you can like const greeting. It's a global, like that global object, native sample model, that basically the model you will create. Some method, you can pass something, and it returns something, and you can use that value in your Java script code. Basically the same. Who of you has ever wrote a native module for React Native? So maybe you're already familiar with that concept, but with native modules dot instead of global. So basically, how it works: we start with Java class, where we define first of all the native method. That method is going to be called from the C++ side. Also, we have the like say hello method. It basically that method from the JavaScript we will call here on the Java side. So basically it hello and concatenates the string we are passing. It's basically the Java string. So next we need to initialize and then install the bindings, and bindings just will be installed by just sending a pointer. Who know what is pointer? Okay, basically it's a value which represents the like place in your memory where the object is like stored. So that's basically the pointer. So we are sending the pointer to that bindings, and that the long is the type of the pointer. Okay, then scary part is starting. C++. Who loves C++? Who has ever written any C++ code? Okay, lots of people. Okay, pay attention, and on the second line where we have that weird-looking name of the function, that basically that Java com Sahaidak test JSI test installer install bindings. That basically that one. Package name, class name, method name. So that basically how we map the Java to C++ via JNI, not JSI but JNI. Okay, then we creating the instance of our sample model. That basically will be the model which will handle all the requests from the JavaScript side to the C++ side, and we can write some logic to invoke some Java methods from that. And also we are calling static method on the sample model called install, and passing runtime. Runtime is basically the pointer to our JavaScript runtime. In our case it's JavaScript core, but it can be Hermes, it can be V8, or maybe Chakra core, who knows. So basically that's the pointer, and you can use that pointer. Pointing it's back basically the object, and you can call some method on that object. And don't like look on those code. If you have some question how does it work, just ping me later or just join the our channel. Next, the implementation of the install method. It accepts the JavaScript runtime. JSI runtime is basically the type of JavaScript runtime, and also the pointer or just a object of our simple module. And then we creating some like name for our module, and you saw on the like several slides ago on the JavaScript side we have global dot and some name, and that basically that name. And the most important part is that one. So you can use runtime that like grab the global object, and you can basically set a property on the global. So basically you assign it just like you used to do on your JavaScript side, and passing its name and also the like our host object itself that will be I will describe later. And also you need to create a get method on your module, a sample module. It basically just regular public method, and it accepts the runtime and also the prop name. That prop name is basically the prop you are going to call on the native module from the global dot native module name dot some property, and you can do some logic, and at the end you should always return something. And we all know, like when you do something on in the console, at the end it returns undefined always. So basically that's the same, you should return undefined at the end. And that's the code right here. So we should like define the logic for our say hello method, and that basically regular callback, like regular function, lambda function or arrow function you used to write in JavaScript, but in C++. Like that callback will be invoked, then we call it from JavaScript side, that callback, and it accepts several things, but the most important is the runtime itself and also the arguments. Arguments is a array of all the arguments you are passing to your function, and it can be string, maps, not maps but objects, values, any whatever you want. And also it should return the create from host function, basically the function, and that callback you should pass. And that basically the implementation of the whole logic, and I won't explain it right now because it's too complicated and you probably won't understand it. So if you want to like know how it works, just find me after the talk and I will describe. But basically we using the that that argument we passed, like the zero argument. Then we create Java strings from that argument. We invoke the Java called object method, and then we like converting from Java to C++, and then we creating from C++ to JavaScript, and then returning something back to JavaScript. Yes, it's basically that chart I showed you where we have global, we have JSI, we have C++, we have GNI, we have Java, then back GNI, and more and more. So at the end of the day, you will have the global native sample model that basically that property we set on the global runtime. Then the say hello, that basically that callback. We are passing the some value that basically accepts in that arguments array, and we are using right here. So and it returns something. You can see like that really returns something. Like at the end of the method we have return result, and basically it's the JSI string. JSI string means that JavaScript string. Remember I told you I was going to tell you a story like about one failure. What is the failure? So, as you remember, JSI was like 3 times faster for reanimated on iOS, and it was only 30% faster on the Android. I'm pretty sure we can optimize that code and it will be like 100 faster, so twice as faster, but still with 30%, if we had like delay in 3 seconds, now we have delay with 2.1 seconds. So still it's slow, and the user don't care about that like 0.9 seconds. That will be just slow. It's slow. Sheet up, not use it. Okay. Conclusions. Bad parts of JSI. It isn't really that faster than the async bridge, and it's hard to write because it's C++. Who really wants to write something in C++? No. Lots of boilerplate. Like you saw that callback. Imagine having like 100 of methods on your object with different parameters and converting to some maps which Java understand, and you will have like a few thousand of lines of code written in C++. It's basically lots of boilerplate, but you can really copy and paste it because it's not the same, but still lots of code. Also, you cannot debug JSI on Chrome, like using the remote Chrome debugger, because JSI is a native thing and it won't use the WebSockets for communication like it using on the Chrome debugger. So basically, we are not we passing the messages from JavaScript to the native when we have remote Chrome debugger enabled. It's basically over the socket sending to the device itself. But with JSI, there's no async reach, there's no serialization, there's no socket, so basically you cannot use it. And the only way to use that right now is to have the Safari debugger, so it will be attached directly to the JavaScript core, and that's not the really an option for me, at least, maybe for you. But still, JSI has its good parts. So still faster than the async reach, and I'm not I pretty much sure turbo models will make it even faster because it got like lots of optimizations and like lots of code with which helps you to do things quicker. It's sync communication between JS code and the native code. So basically, then you invoke something from the JS will wait until native will respond to you. So basically, you can do things synchronously. And you can do asynchronously as well because it has promises built in. So you can just use the promise and it will not deblock the JS thread. Can be used to create native C++ models, and that's a big part of it. But also, there are two projects. One is CodeGen, second one is Turbo Models. CodeGen is basically a tool which will create you all those boilerplates without any like changes. You will define. You just need to write some of the annotations of your like module in Flow or TypeScript, and it will generate the whole JSI reach for you by free. And turbo modules are lots of things which allow you to use those modules and like initialize them not at the start time, but then you actually talk to them. So basically, the app won't initialize all the native modules at once during the startup, and can be used with any JS engine. So basically, we know about JS Core, we know about Hermes, but there is a project called React Native V8. It's basically the JS engine used in Chrome, and you can use that on Android and as iOS. right away with some of the problems, but still it will be usable at some point of time. And on the latest updates of the Apple guidelines, we say you cannot use any of the different 10 JavaScript core engines if you are web browser. But we are building not the web browser, we are building native applications. So probably by Apple guidelines, you can use any of the JavaScript engine you can use in your app. So basically, maybe Facebook is using already Hermes in their apps on iOS. And also, the sync view render via Fabric. Fabric is a new architecture. You probably already heard about that somewhere. But basically, it will allow you to write kinda document create element, and it will synchronously create your element, but on the not the browser, but in React Native world, and it will do that synchronously, and also React concurrent mode, and that cannot be possible without sync view render. So React concurrent mode won't work. And also another thing that you will be able to use request animation frame technique to animate your views in React Native from the JS thread, and basically React concurrent mode will help your code, like the engine, to prioritize the animation itself over all the other tasks like fetching or updating subcache, wherever. So basically, we will achieve the 60 frames per second using only JavaScript sometime in the future. So that's it. Questions?